Chapter 15, Notes. This very first part is your warm-up. Do that on your own and bring it to class. Here's the start of the notes. The question is, what is the probability of drawing a single card from a deck and getting a red card or an ace? You really do need to memorize that there are 52 cards in a deck, 13 of each suit. Hearts and diamonds are red, spades and clubs are black, and there are 4 of a kind of each cards, the numbers 1 through 10, Jack, Queen, and King. Well, in looking at it, the first thing we need to notice is this is not disjoint. If we want a red card or an ace, okay, it could be a heart or a diamond, so there's more than one red card. And I'm going to go ahead and fill out this Venn diagram to make it a little more clear. This could be where your red cards go. Okay, there are 26 red cards, right? 13 hearts and 13 diamonds. And this is where your aces go. There are 4 aces. Okay, 1 ace is a diamond, 1 ace is a heart, 1 ace is a club, 1 ace is a spade. And if you think about it, 2 of those aces are also red. So that leaves 2 that aren't, which would leave 24 red cards that aren't aces. And so they are not disjoint because their overlap is not 0. Now to find the probability, we would just say the probability of a red or an ace. Okay, and that would be this number plus this number plus this number. Notice it is not just adding up 26 over 52 plus 4 over 52, because then we would have added the 2's in the middle twice. Okay, so this leads us to use the general addition rule, which works when events are disjoint and not disjoint. So far we've just been doing disjoint stuff before break, which is, and the rule is, the probability of A or B equals the probability of A or B, A union B, okay, that's the math symbol, which is the probability of A, so it'll be all of the red ones in this case, plus the probability of B, which would be all of the aces in this case, minus the probability of A and B, which would be A intersect B, which is their overlap. Okay, so you have to count the part, you have to subtract out the part that you counted twice. So instead of being 26 plus 4, it's going to be 26 plus 4 minus 2, or 28 out of 52 cards. We had to count that overlap out. That is the probability of getting a red or an ace. Note, when we use the word or, we mean it to be inclusive, which means we are counting the overlap, we're just counting it once. Here's another example. Suppose that 75% of students in statistics are seniors, 90% have a TI-83, and 70% are seniors with TI-83. What is the probability that a randomly selected student is a senior or has a TI-83? So this would be the union idea, okay, or the 70% are seniors with a TI-83, that would be the and part, or the intersection part. So if I were to fill that in, we have 75% of students are seniors, and 70 of those are seniors with a TI-83. So that would be 5% out here that don't have it, 70% that do. And then 90% of kids have a TI-83. 90 take away this overlapping 70, and we have 20% that are not seniors that have a TI-83. So then we just have to fill it in. Probability of being a senior is 75%, plus the probability of having a TI, which is 90%, minus the overlap, and we get 0.95, or 95% chance that if you randomly picked a student out of this population, they would be a senior that also has a TI-83. Sometimes the knowledge that one event has occurred changes the probability that another event will occur. In this case, the events are not independent, and we have seen this before when we did random variables. Your estimate of a probability of being in a car accident increases if you know that it is raining outside. So the fact that it's raining is not independent of the fact that you might get in a car accident. Suppose that the pass rate on the AP statistics exam is 80%. That is, for a randomly selected student, the pass rate is 80%. However, if I know that that student got a B in the class, then the probability increases to 95%. That is, for a randomly selected student, the probability that they pass, given that you have a B, is 95%. And that notation is pass given B. Okay? Probabilities in the form of A given B are called conditional probabilities and pronounce, like I said, the probability of A occurring given that B has already occurred. The following data is about the 2,201 passengers on the Titanic. We talked about it in Chapter 1. Of those passengers, 367 males survived out of all total 1,731 males. And overall, 711 people survived total. We could put this in a two-way table and look with gender and survival as the variables, which is what we did in Unit 1. Reminder, a two-way table is a way to summarize the relationship between two categorical variables. It lists the outcomes of one variable down the left side and the outcomes of the other variable across the top, and the frequencies, or relative frequencies, in each cell. Okay, and so I've done that here. There are a couple of ways to do it, but I went ahead and looked at it, and it says we know that there were 1,731 males, so that would be my total of males. Of those males, 367 survived, so that's where I got this. And then, of course, to get the 1364, I just took the 1731 minus the 367 to get the 1364. And I think you guys could easily fill in this chart. To get the rest of it, if I knew 711 survived, well, they're either boys or girls. So 711 minus 367 told me that there are 344 females that survived. And from there, I extrapolated the rest of the data. You could write it this way, or you could do it with the male and female going horizontally and survive and die going vertically. And I'd like you to complete that chart and bring it to class. Should just be some freebie points. Okay, but we can use this table to answer questions now using our formulas. So let's quickly review. The overall distribution for the gender is called the marginal distribution of gender. 79% are males and 21% are females. So you'd get that by doing, you get the 79% by doing 1731 divided by the total, 2201, to figure out that 79% are males. You could do the same idea to get that there are 21% females. The distribution for a specific gender category is called a conditional distribution. And that would be then that 73% of the females survived and 27% of the females didn't survive. So we're combining them and getting a conditional. We'll talk about that with some examples. Question, how do we display the relationship between two numerical variables? Well, we did that in chapter 7 through 9, and that was with a scatter plot. Okay, how could we display the Titanic data? Just like we did in chapters 1, 2, and 3. Okay, with a two-way table, or excuse me, with a bar chart. Okay, where we have compared them. All right, let's try some practice. I've now taken the table that I wrote on here and I've moved it to this page. The first question is, what is the probability you survived? Well, we know if we add these up, there were 2,201 passengers, and of those total, okay, I had to fix the chart, there was a problem, but let's look at it. We know that there are a total of 2,201 passengers, if you add everything up, and it wants to know how many people survived. Well, of those 2,201, 711 survived. So 711 out of 2201. We could also ask the probability of being male. Well, that would be 1731 over 2201. Then we're asking the probability of being female and survived. Okay, so that's going to be the stuff now in the middle of the two-way table. Female and survived is 344 over 2201. Again, the denominator stays the same because we're still talking out of everybody. Now we're going to say probability of female or survived. Well, you could be a female. There are 711 females. And that includes those that survived and died. But it says or survived. We also want to count the males that survived. So plus the 367 males that survived, which would give us a total of 837. over 2201. Now here's the new stuff. What's the probability of surviving given that you're a female? So we only care about the females, so we're going to change our denominator. There were 470 females, and out of those 470 females, 344 survived. So the given really changes your denominator, and I like to think about it as this being your line, your fraction line, and this ends up being the denominator. Okay, now the question is, what is the probability of being male given you survived? Well, there were, again, 711 people total survived. So we start with the denominator. And of those, how many were male? And we're at 367 this time. Okay, how about died given female? So there are 470 female. Of those, 126 died. So again, this time I looked at the females, and then that 126 of those women died. Female given died. Okay, this time we're looking at the number that died. That's 1490. Of those, how many were female? 126. Notice that this is not the same. Okay, died given female is not the same probability as female given died. They are not commutative. And then finally, female given that she survived. So again, we're out of 711 survivors. And of those, 344 are females. Before I move on, I also want to point out something. Notice that E and G are complements. Okay, because 344 plus 126 would equal the full 470. So either the probability of surviving given you're a female, or probability that you've died given that you're female. And the reason they're complements is because the denominator is the same and the numerator is just the other part of the other question. So let's look at the actual formula, and here it is. We're going to define to have two events, E and F, and it says the conditional probability of an event E given that F has occurred is given by this formula, probability of E given F. That's the same thing as the probability of E and F, all divided by the probability of F, or the idea of both things happening, the probability of both things happening, divided by the probability of the given. And the actual formula for that then, that's the formula. And so we could go ahead and look at the one we did right here using the formula. So the probability of female and survived, well, let's see, out of everybody, females and survived, there were 344. All over the total number of people, 2201. And then my denominator is the probability of the given, so the probability of survived. Well, how many people survived? Let's go back up to our table. That would be 711. All over the total number of people. So here we haven't factored in the given to change the denominator. And if you did that, okay, that's 344 over 2201 times 2201 over 711. So the 2201s cancel out, and you get 344 over 711. This formula is good when you don't have a table, but when you have a table, it's just as easy to do what we did, which was look at the table and look at the marginal totals and use that to get our new denominator and numerator. This will be continued on another video.